taxable income way. Now we're thinking about the government really raising revenue on a grander scale by taxing income, not just what we did last semester with taxing goods. Right? The important point here, first of all, labor supply and deadweight loss. We got this formula given to you on the front page of the exam. Deriving this formula, sort of not necessary. Like, you don't have to worry about how it's derived so much. You're very unlikely to be tested on that. I would say that that's not probably the best use of your time at this point. That said, you want to know how to apply this formula, and also know that this formula is telling you the deadweight loss triangle. Like, you don't have to compute revenue or do anything else. It's actually a lot easier than some of you guys have, at least the questions you've asked me, suggested, which is sort of like, well, what about revenue? It's all in the formula. Like, all you do is plug these things in and do the math out. The revenue is incorporated in there. The behavioral response is right there. It's the elasticity term. So you don't have to worry about, well, what if people's income goes down when you tax them? And you don't have to worry about that. That's already in there. Everything is in there, right? People also ask, well, earnings, don't your earnings change when you're taxed more? Yep, they do. The elasticity term is in there. So you can just keep your earnings at what they were. So if we said you're earning $100,000 and your tax rate goes from 20% to 30%, you might think, well, I have to change earnings because clearly you're going to have a behavioral response. You don't have to, just keep it the same. The tax term and the elasticity term will take care of that piece of it. So just plug in chug with this formula and know how to do that. A couple of just notes about this. So first, the relationship between elasticity of labor supply and deadweight loss. So when the elasticity of labor supply goes up, deadweight loss goes up, which makes sense. When you are more responsive to taxes, when your behavior changes more, if you're like Greg Mankiw op-ed, right? Tax me more, I'll work less, right? You're basically saying that when you tax me more, I have more of an elasticity response, so deadweight loss is higher. Therefore, the logic of taxing people more is not good. It has more strength in that, in that kind of world. If you believe that elasticity is higher, you think that taxes cause more deadweight loss than someone who thinks the elasticity is smaller. So that's an important point. The next one is the tax term is squared, is a square or squared. Sorry, there should be a D at the end of there. The tax term here is 1/2 elasticity tax squared times earnings. It's taxes squared, right? Which is the idea that if I raise your taxes from 10% to 20%, and then I go from 20% to 30%, 30% to 40%, the deadweight loss created by that doesn't just increase by the same percentage, the same amount each time. It actually kind of grows proportional to the square amount of the tax. So, a tax of 10% versus a tax of 20% is not like twice as much deadweight loss. It's 4 times as much deadweight loss. Right? So that's kind of an important point as well, and that's right out of the formula as well. So this formula is telling us a lot, and then a lot of, then we kind of switch gears in a sense, and we said, well, let's talk about the elasticity of taxable income. I don't want you to think that like this is one thing and this is like totally something else. Well, what is this term here? This ES is the elasticity of labor supply. So if I was like, hey, go get some data and calculate the elasticity of labor supply, you'd all kind of be like, what data, what are we even talking about, right? Like the number of hours I work. We're really talking about how hard you work, like how much you try, and how many hours you work. Even how many hours you work is a proxy, right? Because you can work the same number of hours and just try harder or try less hard. So this is really hard and basically impossible, I would say, to measure the elasticity of labor supply. But it's in the formula for deadweight loss, so we really want to be able to calculate it. But we can't really. So what economists have done is come up with this as a good proxy for this. Right, so that's kind of the key point there, is that this is not like, okay, this subject is over, we're moving on to a new subject. This is tied to this, and this is saying, this we can't really measure, so we're going to use this as what's called a sufficient statistic. It's sufficient, it's good enough. It captures a lot of those behavioral responses. Like if you try less hard, you're not putting as much mental effort into your work, then maybe you won't get as big a bonus, you might not be promoted, you might not get that raise, etc. And so that's reflected in your taxable income. Of course, there's problems with this as well, right? Like rent seeking, tax avoidance. Like if you're able to manipulate your taxable income such that your taxable income no longer reflects how hard you're working, like you're working just as hard, but you're being clever about how you report your income, so it looks like you're earning less, right? Then that might mess with the statistic in a way that actually inflates how much you respond to taxes. The key thing, remember, in this deadweight loss formula, what we care about is the elasticity of labor supply. Right? Not elasticity of taxable income, that's just the best we can do in terms of something we can actually measure. But the elasticity of labor supply may be very small, and this might be quite big. And that's one of the arguments that the Piketty size Stress-Cheba, I guess, article is making. So you can go back and take a look at that. That's kind of trying to say that this might be a bad proxy for this. If this is capturing not just working less hard, but also rent seeking and tax avoidance and those kind of behaviors, this number might be 1, and this number might actually, in reality, this conceptual number might be 0.1. Right? So you want to know how to calculate it. Again, the formula is given to you from his exam. So how to calculate it, just write on the exam. The implications of elasticity of taxable income for revenue, we'll try to go through one of those numerically together today. And then this point here, we can use this elasticity of taxable income in this formula, right? Since we don't really observe this. So we use this in its place. So that's kind of what we're saying here. So far, any questions on, any just necessary questions on any of this? No? Cool, okay, we're going to do a sample problem with this. So that's kind of the first kind of area where I'm like, here's a good sample problem. I think there's tax incidents you could do, there's sample problems possible, there's a problem possible here. But I think just for time purposes, we'll probably stick to this one. It's a little bit more confusing. So we'll kind of do one of those. Just the Laffer curve really quickly, the relationship between tax revenue and tax rate. Right, so the Laffer curve looks something like this, right? So we have tax revenue on the y-axis, tax rate on the x-axis. And if we have a tax rate of 0, then we clearly can't have any tax revenue, so we're starting right at the origin. And as we raise the tax rate, we'll start to collect more money. And then at least, it's actually unclear what the shape of it could be. It could kind of take any funny shape, but at least the standard clean Laffer curve as proposed is it looks something like this, right? If your tax rate is 100%, the argument goes that there'd be no tax revenue because no one would work. Because if you work, we just take all of, we take all your money away. That may not be totally true. You may still want to work and do something. If you really love what you do, then you might still do it because it's kind of fun. But we're just kind of approximating here. It'd be pretty close to 0. Very few people would choose to work in that world. And so a couple points. One is it's very easy to kind of be like, oh, I want to be sort of on the top of this Laffer curve. Right? There's no reason why we should be targeting this point. We're not trying to maximize tax revenue. That's not what the government's trying to do. Right? We're trying to find the best balance of sort of taxes and without distorting the economy, but still enough to let the government do the things that we need the government to do. We fight about what those things are in politics, but the point I want to make is not that we're trying to get here. It's just telling us, if we're here, that may be optimal for society. But it's nice to know that if we raise tax rates or we lower them, are we over in this upward sloping part? Or are we kind of back here on this side? And for a while, there were sort of economists who thought maybe we were over here, but now nobody really thinks that anymore. People think we're kind of there. But that said, there's also the possibility that this Laffer curve looks something like this. I mean, it doesn't have to have this inverse U shape. But anyway, that's just a useful thing to think about when you're thinking about tax rates and what we're trying to do here. So,
I have a question.
Yep.
What would a question on the exam about that look like?
So I think it'd be more likely to be something like a short answer, like kind of asking you to conceptually talk about like why is Laffer curve of this shape? Sort of maybe your advisor says like we should raise tax rates because we're on the left-hand side of the Laffer curve, like assess the validity of that argument or something like that. So it's really just more like, do you know what Laffer curve is, and do you know like what it's telling you and what it's not telling you? Right? It's not telling you that this is the best point, right? So it's just more like a possible, it's like a short answer question. I can't imagine there's going to be a question where you have to draw out a Laffer curve or anything like that.
Okay. So is the point that we don't actually know what's at the top of the Laffer curve?
Yeah, we don't know where the top is, and in some sense, we don't really care because we're not trying to get there. It's just a question of, are we left of it or are we right of it? Because if we're left of it and we raise taxes, we should expect more revenue. If we're right of it and we raise the top point and we raise tax rates, we should expect less revenue. But nobody really thinks we're right of the top point anymore. Though some people hold on to that, but most economists don't really think that. Okay, but that doesn't necessarily mean that we should raise taxes. That's kind of the next step, right? You don't want to be like, oh, we're left of there, we can raise taxes and get more money. Well, we're also going to distort the economy, because that is not like the well-being of the economy on the y-axis, right? It's tax revenue. That's not a great measure of well-being necessarily. We may still want to move left. Okay, then we talked about inequality, which is kind of building on some of the redistribution stuff. I won't talk about everything that we talked about in class, but Monica's notes on, especially for the second day of inequality, do a nice job of summarizing sort of the more qualitative side of things. So you'll see that in the slides here. But sort of analytically, we've got this Gini coefficient. I really doubt that you'll have to like compute a Gini coefficient. I mean, you're almost certainly not going to have to do that. But knowing how to calculate it, given a picture like this, is helpful. So knowing that it's A divided by A plus B, knowing that a higher Gini coefficient means more inequality. A nice rule that helps me is like, this is so stupid, I can't even say this. The Gini coefficient goes from 0 to 1, right? And 1 kind of looks like an I, right? So I is for inequality, sort of. So 1 is more inequality, and 0 is no inequality. And that actually helps you remember the formula, to some, at least for me, because I like, even looking at this, I'm like, is it B over A plus B, is it A over, but just kind of go to the extreme case. Total inequality. That means one guy's got all the money. What would the Lorenz curve in that case look like? Well, most of the population's got nothing, and then the last guy's got everything. So this whole triangle would be A, basically. And so A divided by A plus B is going to be 1, not B divided by A plus B. So you can kind of go to, if you're stuck in the exam, you forgot which is above the curve, below the curve, just go to an extreme case where your total inequality and know that the Gini coefficient has to be 1. And then that can kind of help you figure out what's going on.
I agree that we may have to test on the math on this, but if we're not given actually the values for A and B, how could we determine it on our own to then do A over E?
Yeah, I mean, I think that you would either have to be, this is very unlikely, you'd be told the areas, you need to be told, you can't just visually, yeah. You could be, I mean, I could see them asking like sort of,